Okay, so today we're going to do tangent lines and derivatives. And we're going to find the slope and the equation of a tangent line to the given curve. So a tangent line is a line that just touches a curve at one point. Okay, and then you are going to be given the point that it touches the curve. So when you're putting in this tangent line, okay, this is where it touches the curve at one point. But you might be thinking, well, Miss Whipple, it's going to cross this, it's going to touch it somewhere else. Yes, that's true. So you are going to be given a point when it's saying it's touching it at that one point. It is going to be that one indicated place. Okay, and then we're going to find the tangent lines of curves using limits to do that. So in order to find the equation of the line, we have to know the slope. And there's two ways that we can calculate the slope of the tangent line. This first one that we're going to write down, we're going to use that more tomorrow. And the reason why is because this equation works in some cases. There are some cases where it would be a little bit difficult to use this and find the slope. But the second equation, that is always going to work. And so we're going to rely on that equation for today. Okay, so in the first one, it's the limit as x goes to a, f of x minus f of a over x minus a. You may recognize this as the difference of the outputs over the difference of the inputs. Okay, that is something that we looked at when we did the rate of change. And finding the derivatives is very closely related to the rate of change. And then the second equation that we're going to be using exclusively today is the limit as h goes to 0 of f of a plus h minus f of a divided by h. Okay, and that might look familiar because earlier this year, we had to calculate functions that were just f of a plus h minus f of a over h, and we had to simplify those. You guys remember that from way back when? I mean, it was in the fall. It was a long time ago. Okay, so we're going to find the slope of the tangent line to the graph at a given point. Okay, so you're given an equation, a function f of x, and the point 3, 6. Okay, so in this one, whatever you are given as your point is your a and then your f of a. So the point itself, your input value is a, your output value is f of a. Okay, so in our equation, we plug in 3 for a, we plug in 6 for f of a. And then we do have to write out the limit just like we were practicing yesterday. So the slope equals the limit as h approaches 0. And then f of, so if it's a plus h, I'm going to replace a with 3. And then it's a minus f of a. So I just have to write minus 6 divided by h. Okay, so now I need to do the f of 3 plus h. Remember, f of 3 plus h just means in the equation f of x, I'm going to plug in 3 plus h. Okay, so I'm going to write it just on the side here, and then we'll do it together. So this is f of x is equal to 2x. So f of 3 plus h is equal to 2 times 3 plus h. That's what I'm going to be plugging in here. Okay, so this is the limit as h goes to 0 of, and then this is just 2 times 3 plus h because it's 2 times x. Okay, and then when we did this before, we did do some work on the side and then plugged it in. If you want to do that, that is perfectly fine. So if you want to say, oh, f of 3 plus h would be 2 times 3 plus h, and that is equal to 6 plus 2h, and have your next step be this third step that we're writing out, that would be fine. So you'd have 6 plus 2h minus 6 divided by h. Okay, and then we're going to combine our like terms. So we have 2h divided by h. You do need to do this step by step. Okay, it is like our proof reasoning. We did that with the trig functions, where you have to make sure you write out each step, and then you'll divide by the h. That will cancel. And just like we did yesterday, we're looking for when we can do that direct substitution. So I can't do direct substitution here, because if I plugged in 0, okay, then I'd get a denominator that was 0. I'd get the indeterminate value. But I can use direct substitution here. If I plug in 0, which is kind of strange for this one, because is there anywhere to plug it in? No. So it's just going to be 2. Okay, so you do the direct substitution, so your slope is going to be 2. All right, so now we're going to do something similar with part B. So we're going to do the slope is the limit as h goes to 0. So it's f of, and then why don't you guys try to plug that in? So instead of a plus h, what are you going to plug in there? Instead of f of a, what are we going to plug in? Okay, so if your a is -3, you have -3 plus h minus 3 over h. Okay, and then like I said, if you want to just do this on the side, this is your f of x here. So if you're doing f of -3 plus h, okay, this is -3 plus h squared plus 2 times -3 plus h. Okay, you are welcome to plug it in, then you would have to write it out for every single step. Sometimes it's a little easier to just do this sidebar. So when you're squaring that, just make sure you remember that you're foiling. So 9, and then -3 and -3 is -6h. h plus h is h squared. Distribute to get -6 and 2h. Okay, and then if you want to simplify, so you have h squared, you have -6h and 2h, which is -4h. 9 minus 6 is going to be +3. And then if you want to plug it back in at the next step, that is fine. Okay, so you could do the limit h squared minus 4h plus 3. Now don't forget, once you substitute that back in, you still have this -3 here. Okay, so the f of -3 plus h is equal to this. That's what we're substituting in, divided by h. Okay, so 3 minus 3 is going to cancel. Okay, and then we can factor out the h. And then even if you wanted to, if you want to just divide h squared by h is h, -4h divided, If you just want to go from here to here, that is fine. Or you can have this step in between where you factor it out and then go here. Okay, either one of these is fine. So you can go here, factor, simplify, or you can divide and go here. But then you have to do the direct substitution, okay? So I'm going to start writing DS for direct substitution. Okay, and then when you plug it in, you do just have to show the plug-in step, and then you can use your mental math. Okay, so your slope is -4. Okay, so any questions about finding the limits in this manner? So when you find the limit, it is equal to the slope of the tangent line. Okay, so in our next example, here we were just finding the slope of the tangent line. This one asks us to find the equation of the tangent line. Okay, and you're going to be given a point, and then you're going to graph the curve and the tangent line. Now we're just going to do a sketch for these when you're graphing those. Okay, you won't even have to put it on graph paper. And we're going to look at those in our graphing calculator so we can see how those fit together. So the first step is to find the slope. That's exactly what we did before. I'll write the equation up here for us. So this is the limit as h goes to 0. F of a plus h minus f of a divided by h. Okay, so it's y equals x cubed minus 2x plus 5 at the point 1, 4. Okay, so the first thing we're going to do is we're going to find the limit as h goes to 0. Okay, so f of, and then we have the a and then the f of a. So 1 plus h minus 4 divided by h. All right, now this one, definitely going to put this on the side. It's okay if we run in a little bit to this one here. So we're going to do f of 1 plus h equals, so it's x cubed minus 2x plus 5. Okay, so 1 plus h to the third minus 2 times 1 plus h plus 5. So if we're doing 1 plus h cubed, I like to just write that out to take care of that. So we're going to FOIL the first two. 1 times 1, 1. 1h and 1h, 2h. H times h, h squared. And then I'll give you a moment to distribute those. I don't want to go too fast for you. All right, so when you distribute the 1, 1 plus 2h plus h squared. When you distribute the h, you have h plus 2h squared plus h cubed. Okay, so we have 1 plus 3h plus 3h squared plus h cubed. Okay, and then here we are going to have to combine these as well. So it's negative 2 minus 2h plus 5. All right, so then let's combine our like terms when we plug it back in. So we only have h to the third, okay, and then h to the squared. How many h squareds do we have? 3. Sometimes I'll do like a little check. Okay, and then we have 3h minus 2h plus h. Okay, and then we have 1 minus 2 plus 5. Okay, so that's going to give us what? Plus 4. And then here, it's f of 1 plus h minus 4. So we're going to put that minus 4 on there. Okay, and then when we subtract those, we get h cubed plus 3h squared plus h divided by h. And if you wanted to, in that step, you could also factor out the h ahead of time. If you like doing that step, you can also just divide here to get h squared plus 3h plus 1. So I can't plug in 0 here because I still have that h in the denominator, but now I can do the direct substitution. Okay, so like I said, I'm just going to call this ds for direct substitution, and then just show how you're plugging those in. 0 squared plus 3 times 0 plus 1. And then the rest you can do with mental math. Okay, that's the slope. All right, now to find the equation of the line, I'm going to suggest you use a blast from the algebra past. So one thing you guys used to write equations of the lines was y minus y1 equals mx minus x1. I think that's a lot easier than solving and then plugging in the b. But anytime you're finding the equation of a tangent line, it is a line, and you do want your final answer to be in y equals mx plus b form, which we can actually do pretty quickly from here. Okay, so when we're finding the equation of the line, we know that our slope is 1, okay? Our point, 1, 4, that would go in for x1 and y1. And so we'd have y minus 4 equals 1x minus 1. Right, and then we could just distribute. So distribute the 1 is going to give us the same thing. Add 4 to both sides. So y would equal x plus 3. This is going to be our tangent line. All right, so let's graph this and see what's going on here. Okay, so in my y equals, I'm going to do x to the third minus 2x plus 5. I'm in a 5 by 5 grid, so I'm just going to change mine to the 10 by 10. All right, so that's going to be my function. Now, the tangent line, let's go ahead and graph that. you'll be able to see from the graph if your tangent line is correct because it should touch at the point 1, 4. Okay, so go ahead and graph it, and there it is. Okay, see how it touches right at that curve there? Okay, so we're going to just draw a sketch of that here. So I'm going to make this go by 10. This go by -10, but I'm going to have this go by 5s. Okay, so if you're graphing your tangent line, you can start at 3. And you can go up 1 over 1, up 1 over 1. I like to use my straight edge. You also know that you're going to be at that point 1, 4. That is where they're gonna meet. Okay, and when you're doing this on your homework, you don't even need to put it on a grid, okay? I just want to sketch. I want you to look at this in your graphing calculator. I want you to check that you have done the right tangent line. Okay, so this guy, we know it's going to touch here at the 1, 4. And like I said, I'm okay with it. Goes through 2. I'm okay with you just doing a rough sketch of that, okay? But that's a good way to check to make sure that you have your correct tangent line. All right, so we're gonna try this again with part B. We can see our equation's a little bit different. So it's y equals 4 over x, and then I need to give you the point. It's at 4, 1. So this is the entire given problem. So your steps are going to be the same. We're going to find the slope. We're going to find the equation of the line, and then we're just going to draw a sketch of our graph when we're done. Okay, we're going to check it with our graph on our graphing calculator. Okay, and then your first step is going to be to find your slope. Now, when you're finding your slope, you're going to have to use some of the strategies that we've been using over the past couple days. So we're going to do the limit as h goes to 0, f of, and then if it's a plus h, we have 4 plus h for this one, minus 1. And then that's going to be divided by h. Okay, so we're plugging 4 in for a, 1 in for f of a. Okay, now when we plug this into the equation, okay, we have 4 over x. So it's going to be 4 over, and instead of x, what do we plug in? 4 plus h. And then it's going to be minus 1 divided by h. So we have this whole thing, okay? This is something that we practice finding the limits with algebra. So when you have a fraction, in order to undo that fraction on the top, what you can do is multiply by the LCD. So you can multiply the numerator by 4 plus h and the denominator by 4 plus h. So think about what's going to happen. You have to multiply this, and you have to multiply this. Okay, you don't have to write this part out, but when I teach this in Algebra 2 Honors, I have them write it out so they can see what's happening with both of them, right? If you're distributing the 4 plus h, here it's going to cancel and you're left with 4, and then here you have to distribute the -1. Okay, so what happens here is you have the limit as h goes to 0 of 4, because those are going to cancel. And then you have to distribute. Negative 1 times 4 is negative 4. Negative 1 times h, negative h. And then one thing that we talked about yesterday is writing these as the product. Don't distribute. Leave it as h times 4 plus h. Okay, so then we're going to simplify. So for some of you, the hardest thing is just going to be writing out your steps slowly because your brain's working faster than your pencil, which is great because you're going to be able to recognize the patterns. So the h's are going to cancel, right? So 4 minus 4 gives us negative h. Our h's are going to cancel, so I have negative 1 over 4 plus h. So here, if I plugged in 0, I'd have 0 over 0. But I can plug in 0 here and not get 0. Okay, so this is when you're going to do direct substitution. So it's negative 1 over 4 plus 0, which will be negative 1/4. Okay, that is your slope of your tangent line. So then when you go to step 2, your y minus y1 equals mx minus x1. Your slope is negative 1/4. Your point is 4, 1. Okay, go ahead, plug that in and simplify, and then we're going to graph it. So plug that in, simplify, then we will graph it. Okay, and I do want you to graph it on your graphing calculator as well. Okay, so once you distribute, get negative 1/4 x plus 1. Add 1 to both sides. Okay, so you have y equals negative 1/4 x plus 2. This is your tangent line. Okay, so let's look at our graph. So it's y equals 4 over x. Okay, so we have a rational function, and then we can plug in the negative, I'm going to put 0.25 for the 1/4 plus 2. And we can see that it's hitting it right there at 4, 1. Okay, and then I'm just going to change my window, see if I can go by 5 by 5 on my grid here. I can, so I will. Okay, so for my tangent line, if I start at 2, I can go down 1, back 4, up 1, over 4. And again, for your homework, it doesn't have to be as precise as this. The main thing is we want to see this on our, we do want to see it on our calculator to make sure that these are intersecting at the point where they should. Okay, so at 4, 1, we have our branch, we have our other branch here, okay? Okay, so just a sketch of that for your homework is fine. You don't even have to put it on a grid. All right, any questions for me so far? Ready to try this last one? On your own? All right, so f of x equals root x plus 1 at 3, 2. Okay, so I want you to do the first few steps. All right, let's see how we did the first few steps. Okay, so we're doing the limit as h goes to 0, f of our a value is 3, so 3 plus h minus f of a, so minus 2 divided by h. Okay, and then when we are plugging this in here, okay, we're going to get the square root of 3 plus h plus 1. And we do want to simplify that because we can combine the 3 and the 1 together. So this is the limit as h goes to 0 of the square root of h plus 4 minus 2 over h. And then do we know what to do once we get here? So this is what we did yesterday, right? Yeah, we have to rationalize the numerator, and we do that by multiplying by the conjugate. I heard you guys say both of those things. Okay, so what is the conjugate? The square root of? Yeah. So yeah, whatever's inside is going to stay the same. So h plus 4 plus 2. And then, yeah, if you have 4 first, yep, you can keep it like that. Oops, sorry. And then we got to multiply by the same thing. So plus 2. Okay, and then just like we've been doing, when you're multiplying, you can keep things as a product. Start to write the same thing over. Okay, so we're going to rationalize the numerator. Okay, and you can go ahead and do that. How confident are we feeling on rationalizing it without me? Pretty good? Sort of good? Sort of bad? So root times your root is going to be h plus 4. Okay, inside and outside will cancel. Negative times a negative. Negative times a positive, I mean, is going to be a negative. And then we're going to keep this as 2 factors being multiplied. Okay, so then we have the limit as h goes to 0 of, and then, yep, we still have to write this out even though we can see what's going to happen in the next step. I know that will, sometimes that's hard when we can see what's happening, but we got to write it out. Okay, and then when your h's cancel, you have the limit as h goes to 0, 1 over square root h plus 4 plus 2. Now here we couldn't plug in 0, that would make it indeterminate, but here if I plug in 0, I can do direct substitution. Okay, so like I said, I'm just going to write direct substitution. So 1 over. The first step, you just have to show what that is, and then you can do mental math for the rest. So the square root of 4 is going to be 2. 2 plus 2, 4. So 1/4 is going to be your slope. All right, so then we're going to find our tangent line. So y minus y1 equals mx minus x1. Okay, so I have 3, 2, so y minus 2 equals 1/4, x minus 3. We're going to distribute 1/4 x minus 3/4. Going to add 2 to both sides. We could get a common denominator if we need to. Okay, so 8 minus 3 is going to be 5. Okay, so this is our tangent line. Okay, do you guys remember what the square root function looks like? So remember that the square root is the inverse when something is squared. So x to the power of 2, which we know is a parabola. Anything that's an inverse reflects over that line, y equals x. So the square root looks like half of a parabola on its side because it's reflecting over that line. Okay, so if I graph this, you can see it's part of that parabola. Okay, and then let's see how this tangent line holds up. All right, and it will go right at that line there. Okay, so 1, 2, 3, 1, 2. All right. So for your homework, you just have to make sure like you're showing your work here, and then this just has to be a sketch, does not have to be on graph paper, okay? It can be a sketch just right from looking at your calculator. Okay, and this is mandatory homework, all of the chapter 13 is.